Micrometry Datasets is a recent expansion that accounts for the necessity of creating datasets for machine learning implementations and has been recently added to the vanilla micrometry toolkit. The user interface remains simple, and its purpose is to subsample an area of the screen in order to save it with a respective label. Depending on the type of samples that we're using, we can freeze or unfreeze the views just as before. And we also have the edge or motion detection parameter, which allows us to highlight the elements against the background based on a quantification or an average of pixels that reveal a static background. Regardless of how you decide to train your neural networks, whether it is with halftones, which already provides only one channel, although you would need to flatten the image, or you may save it also as a 3-channel, providing the information on the color. Because of the necessity of working fast when you are dealing with animals like this, in this example we have rotifers in the microscope right now, sometimes these guys are really fast and sometimes they decide to move up or down or completely disappear from my scene view. So I need to have a shortcut for freezing the screen, and that shortcut is the spacebar. Whenever you're working with datasets, you can press the spacebar and that will freeze and unfreeze the view. Let's press also S, a new shortcut for select, and that will allow us to delimit a sub area. Let's press the spacebar to freeze the image, and inside of the selecting edit mode, I can left click, and once I define the area that belongs to the organism that will enter my neural network, I can left click once more, and then I can select the prefix. In this case, this is a rotifer, and I can press enter. Compared to other submodules, pressing return doesn't take you back to the original version of the program where you can see the buttons. Instead, if you want to go back, you will need to press escape. However, the freezing and unfreezing only happens now when you click the button or a spacebar. So let's keep doing the selection. I'm gonna select this organism, and this is also a rotifer. I press enter, and now it has been saved. The images will be saved in a subfolder called images located inside of the dataset subfolder of the micrometry folder. If I double click in there, I will see that the category to which the organism that I just sampled belongs to has been stored inside of its own folder. The program creates folders for every label that you type. Here inside of rotifer, I can see the different images that I have taken, not only today, but in the last couple of weeks, of all of the rotifers that have appeared in my samples. Datasets allows us to work fast with live specimens in order to create big amounts of data in a relatively short period of time. Notice also the presence of padding. The padding occurs when you delimit an area that is not perfectly square. The dimensions of the squares are different as well, and this is something that you should take in consideration when you import the models into your program. You should normalize them to a particular dimension. I don't do it directly in the program because different applications may have different requirements. However, something that we do have control over is going to be the type of padding that we add to our images. One of the flags that we can use when running the program specifies the type of padding that we will use. Let's see the different values. Here we are in the terminal. Before the execution of the program, we need to make sure that we are inside of the environment that contains the sublibraries OpenCV and Python, stored inside of an environment called micrometry-m. Here we can type Python, followed by main.py. Normally, you have access to flags that allows us to specify the type of view that we want from the camera and also the resolution. That is CI for camera index. In my case, that is 1 because that is the camera that is attached to my microscope. And then I have res. If you're ever in doubt, you can call main.py followed by -h, which stands for help. And that will give us additional information on the type of values and default values that these flags have. If we decide not to pass the flags, then the program will start with these default values. So in here, the camera index starts with 0 at the beginning. I guess it doesn't say there. There's something to fix. The next one is the resolution, which goes from 0 to 1. The default is 1 because it represents 100% of the original resolution of your camera. And finally, we have pad. And pad, it starts with the default value of black, which is why we see the images padded with black edges. We have random, which assigns a random color, reflect, and replicate. Let's apply the random flag, and let's see what happens. I'm going to press up to bring back the options, and this time I'm going to type CI1 because I know that's the camera index that belongs to my microscope camera. Then the resolution, I'm going to use 0.5 for 50%, and the path will be random. Let's see how our images look. Oop, something happened here. Unrecognized argument CI. Oop, the camera index has to be with double dashes to be recognized as a flag. Also pattern random. Oh, I am making a lot of mistakes right now. I'm sorry about that. So let's press enter once more and hopefully it will open. There we are. Okay, so notice that now the place is getting crowded. The buttons are starting to get a little squinch, so I don't necessarily recommend doing this, but sometimes it's necessary because of performance reasons. Sometimes, you know, less pixels to render makes the computer faster, depending on what operative system you have. But, you know, hopefully you'll get your hands in something that is a little more powerful. Okay, so here we are. And if I remember correctly, I had some rotifers in here. Poor guys are getting squinch. Yeah, there they are. But I think I'm going to start a new class. Let's just use that one. So this guy is moving fast, so I press spacebar to freeze it really quickly. I press S, and then I can select the area in which this organism has been delimited. And just for funsies, I'm gonna make it taller than wider to make sure that I can see the effects of the padding. This is gonna be called a protozoan, and I'm gonna call it Z, just so that I can erase it later, and I press enter. If I go back to the folder Micrometry Datasets, inside of the subfolder images, I will see again the different classes, and you will notice that now a protozoan Z has been added. I enter here and notice that the padding is now, let me see, and notice that the padding now is of a yellow color. Now every time I save a different image, the color will change, and that stops the machine learning application to learn from the edges of the padding. Let's try a different one. This time we will use reflect, and I didn't like the resolution being that small, so I'm gonna set it to 0.8. And while I do that, I'm gonna add some more water to the sample also, because these guys look a little thirsty. Sorry. There we are. And let's take a view of this algae right here. We freeze the image, press S, make it very long, and then I call it algae Z. I press enter. I'm gonna go back one level. This class doesn't have anything anymore, so I'm gonna delete it. And where is my algae? Here it is. And look at what it did. Now, you can imagine this being useful when you have images that capture the entirety of an organism. But if you're not, this may actually impose a bias on your data to always detect objects that are symmetrical. Depending on the application, of course, this may be useful in some circumstances. The last option in the padding is replicate. And what replicate does is simply taking the values in the edges for every pixel and then just propagating it until it completes a square matrix. So let me freeze the image once more. We press S, we take the image, and we call it again algae Z. Once it is saved and we open it, you will see that the image is defined in this rectangular area right in the center. And then the padding has just extended the pixels on the edges. One of the advantages of this program is that you can just keep expanding the values in your dataset unless you move into new projects. In which case, what I recommend you to do is simply take the elements that you have in your folder images and then just move them to a different folder.